Well, first of all, we'll kick off with Harold, who is going to talk to us about the night skies in December, and also particularly viewing Andromeda. So I'll hand over to you, Harold.
Thank you very much, Mike. Good evening, ladies and gentlemen. Last month we spoke about, one of the things we spoke about was Orion. It makes this time of the year very exciting. So I'll be talking about what's up this coming month, but also we're having a look at Andromeda, and I chose Andromeda because we down in the south don't often get a chance to see Andromeda, but at this time of the year we can see it on the northwest horizon. So that's why I'm going to be talking a little bit about Andromeda. But first of all, I'll be concentrating on the stars, planets, constellations. I'm not talking much about deep sky objects, a little reference, but not much. Okay, so I'm going to start breathing again and press the button. And it doesn't move. There we go. All right, so this is looking south. I've highlighted the ecliptic on the right-hand side, showing Saturn just above the western horizon, but I'll be talking about the planets again later. But I just wanted to, there's actually not all that much. Most of the activity is just setting down below the horizon. I'm talking about Centaurus and Crux. But you can see Sirius, the brightest star, up on the left. Then you can see Canopus, which is in Carina, the brightest star there. And I've just highlighted the large Magellanic Cloud and the small Magellanic Cloud. There's not much I want to talk about right now to save the talk for other things. Then pressing the next slide. This is now looking north, and this is where the action is. I've highlighted Orion because you're now all experts on Orion from last month's talk. Then there's Sirius in Canis Major and Procyon, and you can easily see the summer triangle linking the equilateral triangle, Betelgeuse, Sirius, and Procyon. Then I've got the ecliptic. My hand wasn't too steady, but I did as best I could. You can see Saturn on the left, setting in the west. That's in the evening. Jupiter is almost overhead, and Mars is rising in the east. And this is normally at about 10, 11 o'clock at night. Then, if you look over to the left, you have a look at Pegasus. Pegasus is always easy to pick out, and you can see the giant square of Pegasus. And below Pegasus, you see Andromeda Galaxy. And that's what I want to be concentrating on. You can see it's very low, just above the northwestern horizon. I know in the northern hemisphere they see it much more than we do here in the south. Next slide. This is another slide showing Pegasus and Andromeda Galaxy just below it. So to try and pick it up, you can see your Aquarius down to Pegasus, down to Andromeda, to show it in more detail. Now, this is a little chart showing the planets which are visible. Venus at the beginning of the month is just above the horizon, but as the month develops, you see Venus rises up and up. Then we have Saturn comfortably above the horizon. That's quite a bright planet. Jupiter is almost overhead, and then Mars comes quite a way away from the eastern horizon, and Mercury is right next to the sun, so it's not visible at all. So those are the planets. The main three are Saturn, Jupiter, and Mars. This coming weekend will be very good for viewing the stars with a new moon, and also Old Year's night, New Year's Eve. So don't go out New Year's Eve celebrating, rather go and look at some stars. It's much more rewarding. And then, of course, full moon, 15th December, avoid looking at the stars. Next slide. Right, let's talk about Andromeda. Andromeda, we don't, with our naked eyes, and even with binoculars, we don't really get a very good view of Andromeda. We need to move to the edge of the Milky Way galaxy to look over the edge and then see Andromeda. And Andromeda, if we saw it properly, it's about 6 full moons across. So yeah, 6 times larger than the full moon. So it would be spectacular if we could see it from the edge. Maybe one day we'll be able to do that. But it's our nearest galaxy, our neighbor galaxy, and it's big. It's slightly. We did think originally it was twice as big as the Milky Way, but it's not now. The latest statistics show that it's just slightly bigger. This is a picture of showing it as a barred spiral galaxy. So a fairly recent picture. The Andromeda was originally called a nebula, and then as we learned more and more about it, they changed it to Messier 31, a galaxy. Its diameter is 152,000 light years across compared to our 130,000 light years. And it's just around the corner at 2.5 million light years away. We could almost lean across and touch it. 2.5 million is very close. So you'd think if it's moving towards us, which it is, that we've got trouble around the corner. But I'm pleased to say it's sort of moving tangentially to us. We'll come to that just now. The viral mass of Andromeda Galaxy is about the same order as the Milky Way. It's about 1 trillion solar masses, and it's difficult to estimate, but it was long thought to be bigger than us, but not now, by early 21st century studies, that it's smaller than we thought and that we are actually bigger. We've got bigger muscles than we initially thought. So in 2005, an eclipsing binary star was discovered in the Andromeda Galaxy. It was made up of 2 hot blue stars, O and B, and astronomers were able to measure their sizes. And I'm not going to go through the details, but they confirmed that the galaxy is 2.5 million light years away. There are 460 globular clusters in Andromeda, which is far more than we have in ours. And their biggest cluster is globular 1, is twice as big as our biggest cluster, which is Omega Centaurus, which is a big one. So it's twice as luminous as ours. This big globular 1 contains several million stars, which is difficult to get your mind around. And as I said, it's twice as luminous as Omega Centaurus. And you can see those pictures there showed very well. So we all know that we're going to collide, but fortunately the collision is 2.5 to 4 billion years away. So although it's so close to us now, it's 1,000th of the time it's going to take to collide. It's because of this tangential movement. And they've proved this by measuring the blue shift. And the term blue shift refers to the shift in wavelengths of light towards the blue end of the spectrum as an object moves towards us in space. So we can relax. It's more likely that war breaks out with Russia than that we are going to collide with Andromeda. And yeah. So when we do collide, I mean, the distances between our stars and planets is enormous. So it's unlikely that any of them, the stars, will collide, but we'll go into orbits around one another and form a much bigger galaxy between Andromeda and the Milky Way. I've heard terms for it, but I'm not sure what it is now. Yeah. And I think that is the end of my story. That's the end.
Well, thank you very much, Harold. So are there any questions? I think practically speaking, Andromeda is the furthest object you can see with the naked eye.
Oh.
Theoretically, there's the Triangulum galaxy M33, which has an apparent magnitude which is near I think it's 5.7 or something, which is near the theoretical limit of being able to see on the darkest night, clearest night with the naked eye, is just a little bit further away. But whether anybody has really seen that with the naked eye, I don't know. So I think for practical purposes, the Andromeda is the furthest object you can see with the naked eye. And as you were saying, Harold, 2.5 million light years away. So you're actually seeing it as it was when primitive, we weren't humans in those days, but our ancestors were just using the first stone tools, for example. So it's amazing, isn't it, to think?
It is amazing when you think that when the dinosaurs were extinguished was 65 million years ago. And that's a long time ago. So this is very recent.
Yeah.
It's very,
Yeah. Okay. Any questions from anybody? Okay. So we'll